Today, we've got a really exciting tech talk from Dara and 56K Cloud, talk about how you can secure IoT with PARSEC and AWS Greengrass. And I'm thrilled that he can present today. We're really excited to have him today. Before I hand over to Dara, I've just got a couple of little housekeeping things to go through. If you've joined one of our tech talks before, you know the drill if you're joining on YouTube or Zoom, but just want to cover those if you're new to the series. So Dara, if we can head to the next slide, that would be amazing. And I'll just tell people how they can get involved. So you can tweet us at the hashtag #ArmTechTalks. So tell us where you're joining us from, what you've been inspired by over the last few weeks. We'd love to hear from you. And all of these tech talks are available on demand. The slides and recordings go up immediately after the tech talk finishes. So please do check those out if you're interested in this. All past tech talks are on youtube.com/arm. So do check those out. We would love to hear how you're inspired by all the content we've produced. And we've got a bunch of talks coming up, and all of these are available on arm.com/tech talks. But rather than just let you have a look at a web URL and find out what is there, then I'd love to be able to share a bit of a sneak peek on the next slide, if that's all right. Let's have a look at the next couple of tech talks coming up. So we've got Eurotech next week, which I'm really excited about, as I am excited about Kixo the week after. Before we head to Embedded World, so all of these partners that you're going to hear from, and you heard from GitHub last week, are going to be on the ARM booth at Embedded World working with ARM. And we're really excited to have them talking in the tech talks in the next few weeks, and indeed attending Embedded World with us. So I'll talk a bit more about that at the end of the talk and tell you a bit more. We've also got one talk that isn't on the schedule, but I'll give you a little sneak peek as you are joining today's webinar, that on March 21st, we'll be hearing from Remote-It and talking about their integration with ARM virtual hardware. That one's going to be great. So do keep an eye out for that one. I think it should go live on our Tech Talk page by the time this webinar ends. So do head over to arm.com/tech talks for that. But that's enough of the housekeeping and all the boring stuff. I want to get to the content. We're joined today by Dara from 56K Cloud, and it's great to have you here, Dara. I'm going to let you introduce yourself, but before I do, I'm just going to remind people if they want to ask any questions throughout, they know how to do so in the Zoom Q&A box down below. If you're on YouTube, just head over to the Zoom URL I've pasted if you want to ask Dara a question. So thank you so much for joining, Dara. It's great you could give today's ARM Tech Talk. I'm thrilled you could join us. That's enough from me. I'm going to hand over to you, and really excited you could join us. Thanks for joining.
Super. Thanks, Tobias and everything, for inviting us here, to talk and everything, and also that, I could, bring the work, showcase the work that I've been doing in the last 2 years, also at 56K Cloud, along with my colleagues. That we have, how we've been working inside the whole kind of ARM ecosystem, as well as specifically in this talk with PARSEC and the AWS Greengrass offering from Amazon Web Services. So I'm Darius. I'm actually, so my name is, and the accent is from Ireland, but I live in Switzerland. I work at 56K.Cloud. We're kind of a boutique IoT and cloud kind of startup. Well, if you call startup in 4, 5, 6 years. We are based in Switzerland, in the Swiss German speaking area and the French speaking area, so in Sion and Winterthur. We work globally across the world, and along with a lot of our projects are built on ARM. So we'll look at some hardware today. and we also have a focus inside the security aspects of cloud native development. So we're kind of, I've been an ARM ambassador for over 2 years, also a part of the AWS community builders, along with my colleague Joachim, and along with my colleague Joachim as well. He is also working within Docker in the Docker community builders or community leadership, and I'm on the Docker captains program. So, what they are is these are kind of key experts that kind of coordinate together and help the community kind of connect with the new developer tooling and experiences out there, and help to accelerate, those kind of customers or the individuals in those customers to be able to build solutions like here on ARM. So we're looking at one project today, which is PARSEC, and I'm going to give you an overview about that. But to give you an idea, why we present this and show a use case of how PARSEC addresses the security needs, for example, using AWS Greengrass, and also what does AWS Greengrass do in the context of IoT and device management. So just to kind of set the kind of foundation, one of the challenges with developing software on edge devices, particularly if they're connected to the cloud, like if you think of an industrial control single-boarded PC like this Clontron box, which I'll talk later is a system-ready, actually certified platform, as well as like this one. This is an IMX88 from it's a prototyping board from IP SMAC, it's called, and also the other most recent one, like that we've done in the earlier days of PARSEC, is the Macho Adobin Solid Run Marfell 8040 development board. So one of the demos that we've done in the past actually has been on this. There is a new generation of this. This looks more like a network platform with lots of cool interfaces. But if you think about these devices, and if you're developing on them, a lot of the problems you see or challenges that developers face is, what device do I choose? How do I make the best secure implementation there? So, like I said, the ecosystem is quite broad. It's scattered, quite scattered. If you approach it from the outside, there's limited languages. So compared to the web world, I mean, we come from a lot of cloud-oriented projects. So when you're you're mostly living in an embedded C world. And if you look at PARSEC, that's actually developed in Rust. So you're getting a lot more kind of new lower level languages coming into this world. Another challenge is it's a very siloed industry. It's the implementations are usually built on a specific platform. And that, creates a lot of risk when you look at like industrial control, like systems that run PLCs, for example. They're usually like a full stack integrator that builds on top of specific hardware for years, even decades, So, and one of the risks there, as we've seen with COVID, has been that, people need to physically get to the office to access hardware. They need to be able to maintain machines. They need to be able to remotely access systems, and then systems need to be connected. So a reason outside of the business actually created a lot of these specific challenges. And now we see an even greater reason for more abstraction, not just at the software layer or compute layer, but also now at the security layer. Added to that, there's you need a significant amount of knowledge to implement proper secure systems, and they can be very specific, like is it down to the vendors. And one of the challenges today with kind of time to market and delivery is that you have this problem with people trying to get to solutions very quickly. And when you have the world of in cloud kind of moving quite fast, and this idea of iterative development, like I can build a website or a web app in a few weeks, you don't have that in hardware per se. But why can't we not? And so that's why there isn't really an easy way out. And how do we make this more accessible? So this is kind of just a review of some of the current challenges. If people have questions on that, please drop them in the Q&A, because this is also part of the kind of talk, is to stimulate a conversation around that. But when you need to secure something, and just to kind of finish on some of these points, is security now, because it becomes such a high topic since a few years in the industry, it's no longer someone else's problem. Everyone has to think of developing things in a secure way, not just securing the endpoint of a device. The physical access or firewalling it, for example, isn't good enough. We see with the whole kind of crypto Bitcoin kind of craze, when I lose my keys, someone comes and scratches the package on the CPU and actually is able to probe that. So that doesn't mean you can just secure it from the box. Other things, sometimes you have multiple application workloads on these devices, like that Macchiato bin is actually targeted at a NAS. This is a storage network compute platform. And people run Docker containers on NASs. So how does those multiple applications actually access that secure root of trust? And the other challenges as well is the fact that hardware-based root of trust is not so accessible to everyone. But so that's it on some of the challenges and the concerns. I mean, we have to connect the cloud world with the kind of proper hardware embedded world. And one of the offerings from, for example, Amazon Web Services is AWS Greengrass. So what is Greengrass? So if you imagine you have some sort of deployment that's on the edge, in the sense that you have a application use case that operates between a mobile phone or some web service and includes some hardware, like a cleaning robot going around cleaning your house. I mean, that's a connected application that has motors, that has it has a schedule, it has to have a certain level of local intelligence. But if you think about the tooling around that, how do I manage that device? How do I update the software to it? And so AWS Greengrass is essentially, it's also an SDK, it's a library and an application that allows you to manage the workloads, data, and communication on those edge devices. It also is an ecosystem in itself. So so you can build components, and we'll look at PARSEC, how it is actually one of those components that then brings out more value on what you can do on that device. So you've got like on one end, you've got all the cloud services that you get with a with a hyperscaler, for example. So in this case, AWS, where you have your data streams, your kind of monitoring of the IoT device, trying to model it, have a shadow in the background. You also have maybe machine learning. So this is what SageMaker is. You probably have that logging, auditing, debug support, which is AWS CloudWatch. So monitoring your device and replaying messages that may be in the device that you want to also simulate in the cloud. So it brings you to the fundamental tools to build out digital twins. There's a lot of hype around digital twins. Then there's storage, having block storage. So that's what S3 is. It's basically a simple block storage with actually lots of advanced features. And then on the device, management itself, you've got the IoT core. So IoT, AWS IoT on the cloud side next to the device. And so essentially that's what AWS Greengrass is. But we'll get back into that in more detail and look what it is. But to give you an overview on PARSEC, because we're going to look at those two solutions. PARSEC, in its simplest form, essentially a way to abstract your software implementation on your application away from those specific hardware implementations. So you decouple your application development when it requires to talk to a secure element through this kind of shrim, this PARSEC service, and that allows you that if you might have two types of hardware, it could even be different architecture, so CPU architecture, but they might have one might have a TPM, like a trusted platform module, that is physically on the board, and another one might have a secure firmware-based TPM, so it's implemented on the actual CPU. So, for example, that could be here. This is the IMX8 Mini Plus, and it can have what's called opt-T. So PARSEC is sitting between this and then enabling that kind of access and brokerage of the various services. So this could be like, for example, the trusted services there, as I showed. But how does that add value? And why? Why do we need it? Well, first of all, security is not everyone's game. Some people want to build on top of security. They need to use it. It's usually possibly left to the end. And when you work within a developer's world, you kind of want to use the languages that you feel that you know well and that you can work fast with. So it decouples away from having to implement, maybe some ugly C libraries that might be specific to the hardware vendor, so that you can connect that root of trust. It, again, on the portability side, it allows that you can, without refactoring or changing the libraries in your application, that you can just speak with PARSEC, and once PARSEC is on the device, you can have that portability. Then isolation, that's the third important point. When we have multiple workloads on a device, like, for example, this AWS Greengrass, which is doing the device management, the lifecycle of the applications. If you want also your application to benefit from the same secure implementation and the element that it speaks to, the secure element in the background, you need some way for that access to be managed, so the applications can be isolated, so that there can be different key stores, but you're utilizing the same secure element. This is not entirely possible with all the different types of protocols like BKS11, TPM, and 2.0. And then again, PARSEC is a cloud native focused piece of software. It accelerates the development. What I mean by acceleration, it means that someone has put the effort in to build those libraries, those common interfaces across languages like Python, Rust, and what we've done most recently is Java. That what enabled the AWS Greengrass. that means that the developer can work within their own worlds, and you have access to a greater pool of developers rather than just down to people who know embedded C, for example. So it's creating that with that decoupling, it's also accelerating that development experience. And you're not alone. There's a lot of people involved in this. So most recently, I mean, we have seen work that we've done with AWS Greengrass team, along with ourselves at 56K Cloud and ARM, to bring out that Java support for PARSEC. In the early days, we had Docker and Mirantis doing some work in that context, and now we have also packages for the likes of Fedora, and also a recipe for Yocto builds. So there's quite a kind of large number of companies involved in this, and the most recent kind of work has been with the Solid Run on the Macchiato bin platform, and NXP with T. So why is PARSEC part of this Cassini project? So just to give you an idea of where PARSEC sits inside the whole ecosystem. So ARM, has this quite an active engagement in allowing hardware vendors like this is a Contron device, this is an AD-Link device. You can also get it in industrial enclosure. And then I have a Solid Run devices here, is actually helping these ODMs to lift up and bring their hardware to some sort of like security framework or certification. So in this case, PSA, which means that there's some software engineering required on each of the devices. And then at the same time, ARM has a program called System Ready, and inside that System Ready, it's the standardization. So this is the yellow part here, part of Project Cassini. You've got ecosystem, so that's why we're having this talk today. It's part of the ecosystem. There's standardization, which is part of gaining certification for devices like this, so that when you put Ubuntu on this device, when you put Yocto on this device, that it's going to work based on the main upstream mainline Linux kernel. So that means that I can pull a USB key, download the image, and it'll just boot. Actually, to give you an example, the Macchiato bin is actually a Thing S or server ready certified, which means you can even just take Ubuntu's general image from the website and it will just run out of the box, like booting Linux on your laptop, for example. So coupling all of those kind of reference implementations and being able to offer not just the standardization on the software stack, on the operating system stack, why not also at the security layer? So PARSEC is part of this inside the security aspect. So that's what Project Cassini fundamentally is about. It's about all the different kind of OEMs, ODMs within the ARM ecosystem that are using ARM Silicon and how they can reach a system-ready certification towards their customers. So what does that look like in practice? I mean, in most cases, so this is a bit of an opinionated stack to show you what does it look like to run Docker containers on the edge managed by AWS Greengrass, accessing that secure element. So this is some recent work we've been doing since late September last year, where we've been building up on top of the ARM system ready images, a kind of tooling that is focused on running a secure IoT reference stack. That's not just it might not just be connected to the cloud, it could also be working independently of that, but at least, a lot of customer use cases essentially need to come to the same conclusion, So if you're running on say an embedded Linux platform, which is single boarded PC that has maybe a SOM, what you have is that vendor will, have a system ready image, which will probably have ARM trusted services. So you can access that firmware-based TPM, for example. You might have an existing boot ecosystem, so like DK2, which is the system ready kind of label. So that means that your board support packages are upstreamed. You also want to have that secure provisioning of your IoT device management. So in this case, AWS Greengrass, that software itself that actually manages the kind of workloads that are on that device, the applications that are on that device, might be certain set of functions, or what in this context what we call Greengrass components. The device needs to be provisioned securely. It needs to secure its operation so that it's managed from a secure, source of truth. So identity, the identity of the device. So where do you store that? And then secondly, as well, the applications that are working on the device also kind of need to be able to access that security. So in this case, this is why we see some references to a firmware-based CPM on this stack. And so that the idea is for accelerating the development of developers is that they can work on that kind of customer edge services, as we call it here, so that there's that product focus and all the tooling down beneath. You can go to the kind of ecosystem to get that, and that it's standardized. So the hardware could be swapping to a certain extent underneath that stack, but at least you're not reinventing the wheel for every new device you build. So what's available today in the context of PARSEC? So these are the different kind of client libraries you can have. So as I mentioned, the Java client has been the most recently developed, along with the extension of the PARSEC CLI tool. There's a Go library, there's of course the C library and a Rust library. I believe there is in the works a Python client. There is a Python client there that to a certain extent is work in progress. And then on the other end of that, without going too technical, there's the secure backend providers, because normally you would have a TPM or PKS11 library that you would just use, and then you would talk to this directly. But if you had multiple applications when you wanted to talk to it, and how would you manage that? That's where then what the PARSEC support is doing in between is enabling you. When you run PARSEC out of the box, you usually get a crypto lib coming up, a software-based secure element. And then one of the things we're working on for trying to bring out for the embedded worlds, cross our fingers that we can make a demo work, is Opti. So Opti is inside ARM Trusted Services. And ARM Trusted Services is part of the bootloader and the firmware bring up of the device, and PARSEC has a provider in the backend to talk with Opti. To what extent is still a work in progress, but majority of times when you're working with securing your device, you're usually generating a key, you're importing and exporting keys, you're signing, you're hashing, you're doing, random number generators. So those are pretty much green because you can do those now. That's usually the kind of what you want to do. And I'll show you a use case where we bring now PARSEC and Greengrass together. Is that what's happening here is that, PARSEC provisions those keys, directly on that hardware device through the libraries that, Greengrass is using. Then when it connects to the Greengrass, it has to create that security exchange because it has to bring up a client-based certificate in order to build out that identity. So there's some kind of zero-touch provisioning going on. And then when you have those application use cases running on it, the communication between MQTT and HTTP, then the idea is there's an MTLS. But the private key for those MTLS authentication is then managed in the background through PARSEC. And so AWS Greengrass is actually implemented in Java. So we're working with the PARSEC is working with the JC, the Java cryptography architecture, to actually vendor into the Greengrass application in a native way in that space. It's implemented in quite a nice way. So here's an example of such a deployment. As I mentioned, that we have here on the left, we have the PARSEC kind of storing the secure private key and the CSR request. You have this maybe a device independent kind of root of trust. So you have PARSEC running as a service. And then we have the Greengrass device here in the middle. So this is showing kind of two parts to Greengrass. So one is running the device management service itself. And second is actually those kind of customer components. So so what you're building the device for, if it's a edge device to monitor, the lights, or kind of room automation, for example, blinds, or like I mentioned, if it's that kind of Hoover moving around in the house, there's application use case there that you need to program into. But facilitating that communication and everything back to the cloud and the lifecycle of those, you have through two interfaces, the HTTP interface and MQTT. So in this use case, PARSEC is enabling AWS Greengrass to secure the interaction between the HTTP service and the MQTT. So So both the authentication and the encryption of the data back to AWS is using a private key that is stored and generated on the device behind PARSEC. When you build that kind of your application, in a sense, on the side beside Greengrass, you can also then access the same PARSEC service and also give permissions or manage those permissions, where you can also then have your own set of certificates and stuff to manage that. So you not only gain kind of twice, you gain the fact that your life cycle, your device management software is being secured through a hardware element, but your application itself can use the same hardware element and maybe the same keys if you so wish to do that. And that's probably interesting from an IDA identity perspective. Another added advantage is that actually can be packaged as an internal SDK. So usually companies that build out devices, they usually have a few different applications on the same hardware platform. They might have different variants because there might be different kind of product lines. And in this case, you know, you can actually wrap that as an SDK and then give it to your device teams, so that PARSEC and everything is behind that. And then on the right, you have the AWS cloud. So that's where the life cycle is, where you're managing the device. And this doesn't have to be all the time connected, because AWS, you know, Greengrass IoT is about, you know, managing the life cycle of the device whenever it's online. If it's online via a brokerage, like you see kind of another device to device communication down there, because in many cases you usually have one or two elements and be on a factory floor, for example, or typical IoT use cases like a building automation, where one of the devices are connected to the cloud. So that's most on that one. This is an example of a demo we did, where it was a system-ready embedded server certificate. So this was the Macchiato bin, the Marvell. I think the Hummingbird, or one of the other ones, there's a new version of this. This was showing the use case where we had a trusted services element on there, and we're running Fedora with AWS Greengrass and PARSEC. So that there's a video on YouTube, I think, also on this channel, that you can check out a demo from myself and Mark on that. But just to wrap up and to give you, you know, why this is important, why is it interesting to have kind of two ecosystems coming together to really bring that kind of solutions and de-risking that ability to build proper security in your application use cases, is that on one side here on the left, you have the AWS Greengrass ecosystem, focus on IoT and edge workloads. You have the kind of community components. So PARSEC is actually a community component for that you can plug into Greengrass. You have, you know, access to documentation, workshops, and the developer community. So as a AWS community builder, I like to focus on activities that are related to edge and 5G and kind of SaaSification of software on devices. And then on the right side, you have PARSEC and the ARM system ready program. So it really enables to bring those kind of faster turnkey solutions. So if you remember the device stack of the software stack on top of devices, to accelerate developers, you don't need to start by building out the whole, say, operating system builds to build out the software you need to run your application. You can take devices that are already system ready, build the images or take the images from what's been built already, and through that program, those images are continuously updated, and it's made sure that any changes to the hardware, those changes are upstreamed in the Linux kernel. So future builds of long-term support for Linux will still run on devices like that. And that actually requires a bit of community support, because if you're the end user and you're expecting this, you need to ask. You need to ask, I want to see a system-ready sticker on a device, so that you reduce the pain of building your use case. And then on the security side, this is where PARSEC is. So how to get started? You can take some steps. This is the Fedora development. I think a lot of this work was done between Paul Howard and the guys on the PARSEC project. He also has talk that he presented earlier this year in Seattle at Cloud Native Security Con. I recommend also to check that out. You can also catch myself on the PARSEC community channel on the CNCF Slack. We'll also share those links as well. But if you are a Fedora user or if you work within Docker, you can also just take the Docker image and get started in PARSEC. And you don't need to have one of these devices. If you have a computer with Linux or a virtual machine, you can also easily get started. Here's more links to find out. We have a workshop on our GitHub page, which actually outlines to do a demo on the device. It's all done in Docker. So you have the AWS Greengrass running in one Docker container, the PARSEC service, and running in another container. And you can essentially start that. And a few minutes later, you have a full, zero touch kind of provision of PARSEC, of Greengrass, and you'll see your device. And then you can explore all the different PARSEC libraries. Also, PARSEC.community is where you find most community documentation, as well as the Slack I mentioned. The AWS Greengrass webpage, that's where you find AWS IoT Greengrass. It's also a free in the free tier, so it's actually pretty much free to use AWS Greengrass within their free tier constraints. So if you sign up for an AWS account, you won't get a surprised bill. So because there is a large actual kind of free tier to experimentation to that, and I'd recommend joining the ARM Community Builders program to actually increase what you can do there. And also 56K Cloud, we're an AWS Advanced Partner, so we have lots of nice relationships with AWS and connections. So feel free to reach out to us. You can catch us on Twitter, LinkedIn, and on channels like this YouTube channel. So yeah, I think if I don't have any other questions right now, I'm going to hand it over to you, Tobias, to give us some updates on Embedded World.
Sure. Well, before we do, I just want to say what an awesome talk. Thank you so much. And thank you for the shout out for the ARM community builders and everything else you're doing with ARM. You're fantastic and really appreciate all the work you do with ARM. And indeed, today's tech talk is an example of it. So
yes. So there's the ARM Ambassadors Program and there's the AWS Community Builders Program.
Sorry, I thought you said ARM Communities Program. I meant the ARM Ambassadors Program. Sorry, I got the two confused as well.
But the good thing is they're pretty much the same intention,
Exactly, right? Exactly. So no, really appreciate all the work you do with us, and thank you so much for today's tech talk. Really, really appreciate it. Some really great content. As I put in the chat, if you've got any questions, please do ask Dara. I've got a couple. But before I do, just want to remind folks, if you joined last week, you'll know this as well. But we are going to be at Embedded World. Can't believe it's less than a month to go. So if you're going to Embedded World, we'd love to see you. We're at Hall 4, Stand 4, and then Stand 4, 504. So you'll be able to find us. We've got a variety of demos there, including working with 56K Cloud. And a bunch of other partners, so do check those out. We've also got a variety of talks at that event. You can find out all the details you want to at arm.com/embeddedworld. We've got all the talks listed there, the partners we're working with, and more. It's going to be a really great event. I'm super excited to be going and to meeting folks there. So if you're there, look forward to meeting you. And Dara, I believe, are you going yourself to Embedded World?
Oh, yes, of course. And I think there's also a ARM breakfast as well that I think would be also we should have a shout out for. So let me.
We absolutely should. Have you got? If you've got the details to hand, feel free to share.
Yeah. So two things to watch out for on in Embedded World. Yeah, if someone wants to say that they're at an Embedded World, please drop a message somehow on the chat. Happy to meet. So it's from the 13th of March till the 16th of March. So 2 or 3 of the interesting events that are going on is IoTstars.com. So IoT Stars, which usually have pretty cool meetups at MWC and Embedded World. So I'd recommend to check that out. The other one is there's, I believe, a breakfast. So
yes.
And so you'll be able to meet some of the ARM ambassadors. You can sign up. There's probably going to be limited space, but I believe it's on the 15th of March, 9:30 till 11 o'clock in the morning. So that's the event there. You get a chance to meet, ARM experts. Hopefully, maybe, I don't know, Tobias, are you making your way as well to Nuremberg?
I will be there, and I was about to say you're doing I literally covered everything there. So you should come work for us. You covered literally everything. It's going to be so great. I'm super excited for that on Developer Breakfast. So, please do do reach out to that. So I've seen Darius has actually pasted it to me. Sorry, Dara, you've not got permission. You should do, but unfortunately Zoom hasn't given me permission to post to everyone. So I'm going to copy that message that you've sent to me to everyone, and they can go and register their interest. It's also on that web page, so you can find it in a variety of ways. Please do register your interest for that breakfast. We'd love to see you there. There's a whole bunch of topics I think that'll be covered during the meetup. I think from Matter and IoT, app development with Car Studio and virtual hardware, Visual Studio Code. So whole bunch of stuff. I was going to say, if we go back to the links, that's awesome, because I know people like to go and search stuff. So arm.com/embedded world's pretty easy. We've put that in the chat. These are the rest of the links if you want to engage and chat with things. So
any questions? Actually, I saw a question popped up.
Yes, it seems to have disappeared weirdly. So I'm not sure what's gone on with Zoom there. But yes, if anyone's got any questions, please do ask them in the Q&A. I've got one very quick question. Do you have an example of any hardware you particularly want to highlight that is system ready, compatible, sort of system ready?
So actually the ones I was showing here. So maybe, I don't know if I stop sharing my screen, I'll probably be able to show this stuff better.
Yeah, let's do that. I'll spotlight you as well to make sure that folks can see you really.
So two pieces of hardware. Let me go one. So first, the quickest way to get started, which is nice, is this is the IPI. It's like a Raspberry Pi kind of clone, but for industrial use cases. So this is the SMAC, based on SMAC, so 80-link IPI. It's quite an easy. Everything's included in the box to get started. You can have Ubuntu, you can have Fedora, Yocto, and everything. So the nice thing is well documented, and it's also a system-ready certified device. It's also built on the IMX8 Mini Plus, so that's what the device looks like. And this is the module here, and then you can place the device on top. You can actually change out the carrier board with with a different CPU architecture. So that's actually even really nice that it's very expandable and takes about 2-3 weeks. So it's pretty quick to get that device. Something that's a bit more complete, which we also enjoyed working with, is Chrontron from ST&T Group. This is made in Germany, and this is kind of a ruggedized device. It has CAN bus, so for automotive and for industrial application use cases, you can use this. This one is, I think, the 2 gig with 32 or 2 gigs and probably 8 gig, 1 gig and 8 gigs, I think, of space. And this is the mini. So this is an IMX8. Actually, that's a 6 one, but there's an 8. I have an 8 mini one over there. Just the enclosure is exactly the same. And so that's another industrial device. The other one that we used which is, you can still buy to a certain extent, but it's actually a lot easier to work with than those other devices. So if you're looking for something that you want to run a firewall or just plug it in at home and have some easy, familiar interfaces like system builders have. So you have a PCI Express interface here. So I think it's a 4-lane. You have 3 SATA interfaces. You can put in a M2 SSD adapter in there as well. And then you've got 10 gig SFP plus interfaces here. So this one, it's pretty nice. You can hack away with this, but there is a newer generation, just to be aware, that Armada brought out. And the other one, I don't physically have one, but if you look up the guys from Solid Run, they have the Hummingbird, and that's also a nice device. So maybe people always tell me not to walk out of the screen camera. These guys, Solid Run. So
you're getting hardware. You're showing people stuff. It's awesome. This is like, I love the show and tell bit. This is great.
Yeah, but that's what we do over in the innovation channel, innovator channel. With
exactly.
So every Thursday evening around this time, usually see myself and Robert Wolf from the ARM Ambassador Program, and he's showcasing lots of show and tell. We do this thing where we take the camera and show our stuff. So yeah, we're hardware people. You know, there you see, it's a very busy hardware lab.
It's absolutely.
Yeah, that's what you want. That's why you have to be back in the office. You know, there's stuff from the Unify guys as well. You give shout out to those guys. They're doing industrial PLC stuff.
I'm loving it. I'm loving it. Well, that was great. When I was thinking of that, we got that question. I was like, oh, you just probably talk about the hardware hypothetically. And it's like, no, you actually got it to hand. Show it. There you go.
Yeah,
So,
yeah.
if anyone's interested, definitely go out and try and secure one of those devices.
And I have to give credit to one of your colleagues, Mark, Menyon, and I think Imran. They organized, we have actually 2 of the first 64 core Ampere boxes there. So it's a 64 core ARM system, and you can't see it with the big rack now in the way, but it looks like this gaming PC, but it's actually a serious piece of kit. So maybe I'll just and you'll see that on the same website as these guys.
Yeah, exactly.
So yeah, I think that's it. I was hoping I saw.
Have we got? Yeah, I was going to say, are there any other questions? I think saw the one you answered about the slides. Yes, they are literally going live immediately after this tech talk, and they'll be live on our website. So do check those out. If you've got any issues finding them, just ping me. We can make sure you find those easily. So, are there any other questions? This is your last chance before we wrap up. As I say, really looking forward to seeing folks at Embedded World. Please do we'd love to hear how you're engaging with the System Ready program. And of course, as you mentioned, Dara, there's loads of great ARM content, including the Innovation Coffee on a Thursday afternoon, Thursday evening UK time, hosted by my colleague Robert Wolf. So if you like that kind of stuff, then do head over to that channel as well. And you've also got the ARM Tech Talks. You're spoiled for content from ARM. So we'd love to see you at either of those. So if there's nothing else, I think, Dara, have you got any final words you'd like to wrap up with? Any final things you want to ask people to do, or anything else you'd like to wrap up with?
Well, certainly look at, there's a Eurotech call, also a talk. Give my regards to the guys at Eurotech, because they also are using PARSEC in their device, and they, I believe, will also have a so yeah, Marco, I believe, yeah. So check out his talk as well as the others, because it's a nice ramp up to Embedded Worlds. We'll be there definitely from the Monday onwards till the Thursday, and also head over to the AWS booth when you want to know more about AWS Greengrass as well.
Definitely. No, looking forward to seeing folks there. And Dara, really appreciate great presentation. As you say, next week is going to be yet more of this great content from Eurotech. So
yes.
Looking forward to having Marco and Luca from Eurotech presenting. So
yeah, so that's why the demo wasn't in the talk. You have to come to the conference for the demo.
Exactly. That's why you want to come, right? There's one reason to come to Embedded World, and you've got the breakfast, and you've got so much more. So make sure, we'd love to see you there. So Dara, this has been a great tech talk. Thank you ever so much. Audience, thanks so much for your attending today. If you've missed any part of today's tech talk, the recording's available immediately on YouTube on the live stream, slides on arm.com. We look forward to seeing you next week for another of our ARM Tech Talks for all the latest in trends, technologies, and best practices from ARM and our ecosystem.